All right, celebration noises all around. We finally made it to the very last episode of this lesson. Um, and it is an oldie but a goodie. It's something you've seen for years. You've seen it in 8th grade. You've seen it over and over again this year. It is good old rate of change. Please, 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 please get it in your head that rate of change is the same thing as slope. Okay, so it is just the slope of this line, and I tend to use those words interchangeably. So if I'm talking about rate of change and I say slope, sorry. If I'm talking about slope and I say rate of change, sorry, it's the same thing. Also, sometimes you'll hear it say average rate of change. And the reason we use average rate of change is because when you're looking at a curve, something that's not a linear function, you're not going to have a constant rate of change. It's not the same across the entire function, and therefore we kind of take the average over a specific interval. So the change in y value, the definition is the change in the y values divided by the change in the x values. But you can't just pick any 2 points here. So I should have typed some in the notes, but I didn't. So I'm just going to make it up right now. I want to find the rate of change over the interval. Let's say, for example, let's do from 0 to 2. Do I want to do 0 to 2? Yeah, let's do 0 to 2. Okay, that's the interval that I want to use, which means I'm going to go from here to here. Now, if you have the graph, then you can always just do rise over run. You can say I'm going up 1, 2, 1, 2, 3, and over 1, 2, which gives me a rate of change of 3 over 2, because remember, this is just rise, that's your change in y, over run, that's your change in x. You could also do it algebraically though. Our y2, the y2 value here, this point is 2, 4, and this point is 0, 1. So my y2 value is 4, that's my second y value, minus my first y value, which is 1, over my x2, so my second x value is 2, minus my original x value, which is 0. 4 minus 1 is 3, 2 minus 0 is 2, and you get 3 halves. Okay, so regardless of how you do it, you end up with the same answer. If I had just given you the equation and I asked from 0 to 2, then you would need to plug in 0, get the y value that goes with that 0, so you would plug in 0 and get 1. You'd need to plug in 2, get the y value that goes with that 2, which would be 4, and then do that same slope formula. So that would look like this. You would have 2 to the 0, because that's my first value, and that gives me 1. 2 to the 0 is 1, because anything to the 0 power is 1. So that means I have an x value of 0 and a y value of 1. And then I would say 2 to the second, because the second part of the interval is 2, and 2 to the second is 4. So my ordered pair there is 2, 4. And now I'm ready to use that same y2 minus y1 over x2 minus x1. Okay, when I look at this one, I'm going to pick, normally we'll give you the interval, so don't think you're going to have to do this part, but let's go from -2 to 3. Okay, the slope from -2 to 3, I am going up 1, 2, 3, so I'm rising. Let's write down the fact that not -2 to 3, I apologize. -2 to 0. The y value there is 3, the x value is 0. I do that all the time, I'm so sorry. -2 to 0. This is the interval that I'm looking at. My x value here, that ordered pair is -2, 0. This ordered pair is 0, 3. Okay, so that is going to be a change in y of 3, because 3 minus 0, y2 minus y1, also because I'm rising 1, 2, 3, over x2 is 0 minus x1 is -2. 3 minus 0 is 3, we already said that. 0 minus -2 becomes plus, and so I have positive 2. And that's because I went up 3 and then to the right 2. So I got the exact same slope as over here. But notice that if I had used a different interval, let's say I went from 0 to 1, if I had just done this, now I've got a rise of 1/2 and a run of 1, which equals 1/2. That's a whole different slope over the interval from 0 to 1 than what I got when I had the interval -2 to 0. If I go from 0 to 1 here, then I'm going from 0 to 1. That's going to be a slope of rise 2 and run 1. That's a whole different slope. So you've got to pay attention to what interval we're asking for and make sure you're looking at the right points on that line, because it is going to drastically change as you move across. If you look at the slope as you get closer to the asymptote, that slope gets closer and closer to 0 because it's not very steep at that point. When you look at the slope as your values, as it's really, really approaching infinity, that slope's going to get closer and closer to undefined. It's going to get steeper and steeper and steeper. And here it gets steeper the larger x gets. So you've got to pay attention to that interval and make sure you're reporting the right information. All right, go ahead and get to work on your practice. We put it all together for you. There is also an application, so please make sure you do both the practice and the application and check your answers before starting the mastery check. Let us know if you have any questions. Bye-bye.